This video introduces an important concept known as a reference, and references are especially important when we're dealing with data like lists that we can change the internals of. Those are known as mutable types of data. So up until now, we've been picturing variables as boxes in memory, and we've been picturing the values as being inside those boxes. So for example, if we have num1 and num2, and we assign integers to them, we've been picturing what's happening in memory as something like what you see here. And it turns out this is an okay picture if you're dealing with things like integers, but it's actually an incomplete picture. What's happening actually in Python when we assign a value to a variable is we're not actually storing the value in the variable itself. The value is somewhere else in memory. So in this case, if I'm assigning 7 to the variable x, 7 is not inside the box for x. It's somewhere else. And what's actually stored in x is the memory address of that value. So in this case, you can see that the value 7 is in memory address 4001, and so what would actually be stored in x is that memory address. When a variable stores a memory address in this way, we say that it is storing a reference to its value. Another term that is sometimes used is a pointer. And because we don't actually know the memory address and we don't care about it really, when we draw references, we're going to use arrows to represent them. So here you can see I have an arrow going from the variable x to its value, which is 7. Now, if we have a variable that represents a list, it holds a reference to the list. So here you can see we've got the variable prices. We're assigning it this list of values. So prices holds a reference to the list, and you can picture the list as a collection of boxes that are right next to each other. And then each of those list boxes, each of those elements, holds a reference to one of the values in the list. So the list is really a collection of references. It's important to distinguish between mutable and immutable data. In Python, strings and numbers are immutable, meaning that we cannot change their internals. We can't change what's inside a string or what's inside a number. But lists are mutable, meaning we can change the contents of the list. So for example, if we have this list of 4 integers and we assign it to the variable prices, we can change the internals of the list by doing an assignment that looks like this. So you can see I'm taking the value 50 and assigning it to position 2 of the list. And then if I print the list, I will see the change. So I've modified the internals of the list, and that's why lists are considered mutable. You cannot do that with a string. You cannot do that with a number. And so they are referred to as immutable. For example, consider the case in which I've assigned 7 to x. Now again, the real picture here is x is somewhere in memory, 7 is somewhere else in memory, and x holds the memory address of the 7, which we're representing as an arrow. So x holds a reference to the 7. And because 7 is immutable, I can't actually change it. But that doesn't mean I can't change x. I can still use an assignment to change the value of x. But what does that mean? It doesn't mean I'm changing the 7. I'm creating a new value somewhere else in memory, and I'm making x refer to that new value. So I've changed the reference that is in x. I haven't actually changed the 7 itself. What about when I have a list? Well, because lists are mutable, I can change the internals of the list. We already talked about that. And here's what it would look like in memory. So here's my original list of prices. And again, we have a collection of references to the individual values. If I then go and do this assignment to prices 1, what am I doing? Well, again, I'm not really changing the 10, but I'm creating a new value, which is 50, and I'm making prices 1 refer to it instead of referring to the 10. So here again, I've changed a reference, but in doing so, I have changed the internals of the list. Now I can also make a list variable refer to a completely different list. So here is my current list, prices. If I do this assignment, what's going to happen? Well, I'm going to create a new list in memory containing those 3 values, and the assignment is going to make the variable refer to that list, and it will no longer refer to the original one. Now it turns out that we can simplify our mental model. If we have a variable that represents an immutable value, a number or a string, we can picture the value as being inside the variable's box. It's a simplified picture, but it turns out to be good enough for any kind of conclusions that we need to draw. Similarly, if we have a list of immutable values, we can picture those immutable values as being inside the boxes of the list. However, we do need to still have the picture of a reference when we are using a variable to refer to something that is mutable. To see why the concept of references is important in the context of mutable data, let's remind ourselves of what happens when we copy the value of a variable. If we do an assignment in which we're taking the value of one variable, var1, and assigning it to var2, we're copying what's inside the box var1 into the box var2. So for example, let's trace through this code here. X is assigned 50, and again, in our simplified model, we're going to picture the 50 as being inside the box. Then, when we do this assignment, what we're doing is copying what's in X into Y. So in this case, we're copying that value. Now again, this is a simplified picture, but it's good enough when we're dealing with immutable data. When we have mutable data like lists, it's important to have the full picture. What's really getting copied? So here I have the variable list1, which represents this list of integers. And when I copy list1 to list2, what I'm really copying is the reference. I'm not creating a second list. I now have two references to that same original list. And therefore, if I go ahead and modify what's in position 2 of the list, and notice I'm doing it using the variable list2. But because there's only one list, that change, which overwrites the 9 with a 4, is going to be visible whether I use list1 or list2 to access that element, because there is only one list. And so the output is 4 space 4, not 9 space 4. So the important lesson here is when you copy a list variable, you're just copying the reference. You're not actually copying the list itself. If we do want to copy the list, we can do it by performing a full slice, a slice that starts at the beginning and goes all the way to the end. That does give us a copy of the list itself. And now, if I modify position 2 of list 2, that's not going to change what's in list 1. And so when I print the same thing as before, I'm now going to get 9 space 4 instead of 4 space 4. Understanding references also matters when we're passing a list into a function, because what we're really passing is a copy of the reference to the list, not a copy of the list itself. And as a result, if the function makes any changes to the internals of the list, those changes are still going to be there when the function returns. So consider this program. We have one function called main, and that's how we're going to start the program. And it begins by assigning a list to the variable a. It then passes that list into a function called triple. Triple uses a loop to change each of the components of the list, each of the elements, replacing it with 3 times its original value. And then when we get back from the call to triple, we print a. And so we're going to see the changes that were made by triple. And here's why. Before we make the call to triple, we have a stack frame for main. And again, what's really in a is a reference to that list. The list is not in the stack frame. The list is somewhere else. And the variable a, which is in the stack frame, holds a reference to that list. Then, when we pass a into triple, we're going to get a new stack frame for triple, and its parameter is going to get a copy of the reference in a. Notice we're not getting a second list, we're just getting a second reference to the original list. And therefore, as we start to go through triple and modify each element one by one using our loop, we're going to be modifying the original list, And when we get back to main, we're going to print that modified list. And so we will see the changes that were made by triple.